Hello and welcome back to another video. In this problem, we're told if r is a rational function, use exercise 57 to show that the limit as x approaches a of r of x is equal to r of a for every number a in the domain of r. So what does exercise 57 show? Well, it's saying for any polynomial p, the limit as x approaches a of p of x is equal to p of a. So we basically proved that this relationship is true for polynomials. Now we have to show that it's true for rational functions. So if we have the limit as x approaches a of r of x, well, what is a rational function? A rational function is a fraction where you have a polynomial on top and a polynomial on the bottom. So this is the limit as x approaches a of f of x over g of x for just an arbitrary f of x and g of x that correspond to an arbitrary r. Right? It doesn't matter what polynomials we're dealing with, it's just true for any rational function. And since we have the limit of this fraction, we can take the limit of the numerator over the limit of the denominator, right? By the limit laws, this is like the quotient rule or whatever they call it. And we just showed for these polynomials, or for any polynomial rather, the limit as x approaches a of a polynomial is just the value of the polynomial at that value of x. So this is f of a over g of a. And r of a, right, so if r of x equals f of x over g of x, r of a equals, plugging in a here, f of a over g of a. Therefore, the limit as x approaches a of r of x, therefore this limit equals r of a, because they both equal f of a over g of a. And again, just arbitrary f and g, but for those arbitrary f and g, which means for any rational function, the limit as x approaches a of a rational function is equal to the value of the function at that value, if there is one, right? If g of a equals 0, then the limit doesn't equal the value of the function because the value of the function doesn't exist, but that's why we specify for every number a in the domain of R.